Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You start by writing down what you know, r, delta, v0, and use g equals 9. 81m/s2. Next, set axes, x horizontal and y vertical, so you can separate motion. This matters because horizontal motion is constant and vertical involves acceleration. Decompose v0 into v0x equals v0 cos theta and v0y equals v0 sin theta. Do this now. Then write the two kinematic equations. xt equals v0 xt and yt equals v0 y. Once you have t equals r divided by v0 cos theta, substitute that expression into the vertical equation for yt. Doing this eliminates time and produces an equation with sin theta, cos theta, or tan theta. Then use trig identities. Sin theta/cos theta equals tan theta, and 1/cos 2 theta equals 1 plus tan 2 theta, so you can convert the equation into a quadratic in tan theta. Solve the quadratic for tan theta. Choose the physically relevant root, and then compute theta equals arctan tan theta. Make sure units remain consistent. Now compute theta by taking arctan of the selected tan theta value. Convert to degrees only if required by your context. After finding theta, plug v0x and v0y back into xt and yt to reproduce r and delta. This confirms your solution. If numbers don't match, check common issues. Sign errors in delta, wrong g value, or misuse of plus/minus roots. There can be two valid launch angles, low and high, for the same speed and range. Pick the one that fits the scenario.
Thanks for watching. Consider subscribing if I helped unscramble your problems.